What is happening, YouTube? Well, today is a great day because I'm finally going to get around to building the PhilStudio Quad Modulator version 3.1. This is going to be quite a project. He sent this to me as a gift back in February, and it has taken me this long to be able to get around to finally build it. But I'm not going to waste time talking about how I don't have time. Let's just get into it. And first of all, I want to state that because this is going to be a hard video for me to make, I'm just going to go ahead and release this in parts. I'm not going to try to put this together into one big monolithic video and edit everything together. So yeah, we'll leave it at that. So what is this? This is going to be a quad LFO of sorts. It uses a CD4093 IC, which is a Schmidt NAND gate, and you can use this to produce square waves. So as we can see over here, I have one on the breadboard, and we can speed up the oscillation and slow it down. And it uses a resistor, so I'm using a pot as a resistor here, variable resistor, and a capacitor to control the rate. Here is the schematic that I'm provided with, and there's some options. This is very, very interesting. We've got some inputs and some outputs, and we've also got some voltage outputs that we can use. So I've got like crazy options going on right now, and rather than just like putting this together and soldering everything together, by the way, this is how it came. I have not soldered any of these three components on, actually four components on myself. This is the way that it came. It also came along with this really nice 3D printed case that I can use to keep it sort of safe. Pardon the camera movement there. But you know me, I'm going to need something a little bit more than that. What I've decided to do is use an actual enclosure. So I'm going to try to fit this into here and see how it works out. And not only that, this is awesomely glow in the dark. So we'll see how that works out. It's probably not going to pick up too well in the camera, but you can see a little bit of the green there. Okay, I'm going to take a break and we'll move on. So one of my first challenges is making sure that I'm going to be able to use this with all of my other gear and not have it damage anything. And what I mean by that is there are certain guitar pedals that I might want to use, and they only accept a control voltage in the range of 0 to 5 volts. And depending upon how much current is coming out of this, some of those guitar pedals may or may not like that so very well. So I've been struggling with the idea of should this be running at 9 volts or 5 volts. And what I can do is I can use this space right here to create like a little daughter board, and I can actually install my own voltage regulator. So that way I can use a 9 volt source or maybe even a 12 volt source, and I'll be able to regulate everything down to 5 volts. Now the reason why is because we have these 4 voltage points coming out. And what I'm going to do is I'm going to utilize these as the default input for each of the 4 gates. And this will produce a natural oscillation with the capacitor and the resistor in place. As we can see here, this black jumper here is going into the positive voltage, 9 volts. If I remove it, then we just get a sort of intermittent state. So what I want to do is remove this diode, which I don't really agree with. I believe you need to have a fuse in place that will break the circuit. What I would like to do instead is put this in series across the positive, so the positive goes in. The way that it's set now, there's no voltage drop. I'm not going to worry about that because I'm going to have a 5 volt regulator, so this will all go on a little daughter board, and I could probably use this little spot right here to install the daughter board, and we're good to go. Another issue that I'm working on, here is some of the hardware that I'm going to be working with, is whether or not these awesome little 1/8" jacks are going to fit in my enclosure. And my enclosure here, if I can pick it up and move it very quickly, has a lot of the hardware that I'm going to be working with. We've got 4 potentiometers to install and 4 switches to go back and forth between the high and the low capacitor, the high and the low frequency. I'll talk about that later. That's another modification I want to make. And these will be the 4 switches that control the default voltage here going into each of the first inputs of the gates. So as I stated before, the issue is whether or not these awesome little jacks are going to fit appropriately well enough into the enclosure. Hopefully they will. So what I can do is I can experiment with drilling the first hole into the enclosure, and I'll start by drilling it very, very small, just enough to fit this into it, and I'll see how well it fits. And probably what I will do, you may not be able to see well, but there's a black line across here, a line in pencil graphite. This is where the PCB is going to lay down inside of here, I believe. And so the DC jack is going to be somewhere around here. I'll probably start with it, start by drilling a hole here, and then I'll see how well this fits. I'm just going to assume that the side is the same thickness as the top. And now we are out in the garage. I'm going to try my experiment now. I'm going to go ahead and drill the hole for the DC jack. I've decided it's going to be up here towards the top next to the PCB. And my other hardware is going to be installed around here, so it should not be in the way. And I'm just going to try drilling a small enough hole to see how well this thing installs. And then I'll know if these are going to work for this design or not. Before I do all this though, I'm going to first lightly sand this down and get it ready for painting on, and then getting the final matte finish on top of it. That is going to do the trick. These will fit just barely, but well enough. This is actually about as flush as it can get. That's awesome. The power jack will come in this way, I suppose, and then I will have these jacks are actually going to live over here like a patch bay type kind of style thing. And I wanted to make sure that I could actually mount these in the enclosure, because I'm not going to be able to mount them on the PCB. But I'm going to go ahead and finish drilling this hole to the size of the DC jack now. So far so good, but now I've come to a really tough part. I need to get these 4 potentiometers installed into the enclosure just in this tiny amount of space that you see right here. And then on top of that, I want to add 4 more switches. We get one here, like 2 right here, and then another one right there in that corner. This is going to be really tough, so I want to sit here and think about it for a while and try to figure out how I'm going to measure this and get this right the first time. Wish me luck on this one. These 4 switches have now been installed, and what I need to do is carefully line up these 4 potentiometers and see if I can install them. One problem that I'm having is I'm using this graphite pencil, and I'm getting a lot of dirty marks on the front of the enclosure, but I think I'll be able to clean that off later. Another problem is that I said that those 1/8" jacks are going to be able to work. It turns out that they're not. The top plate here is actually thicker than the sides, so I'm going to have to come up with some alternatives, and I'll talk about those later. Let's worry about these potentiometers first. That is a very tight fit, but I can work with that. I would have liked to have gotten this maybe a little bit closer to the switch, but on the flip side, when we flip it over, you'll see that the potentiometers are really a little too close to the switches. I'm going to have to worry about what kind of knobs that I can use now. But everything is fitting okay. Let me get this out of the way for the moment, and we'll turn this around and take a look at it. So this is what we have so far. That's going to be the power switch. These will be for the oscillators or LFOs, whatever you want to call them. And there's our DC power, and we'll work out the rest from there. I don't know. I might be able to. I think I will. I might be able to get the output jacks here, and then I can use 1/4 inch. So that's the idea now. It really pays off to sleep on things before you make a decision, especially when you're improvising. I think I'm going to be able to use these 1/8" jacks as I originally intended it to here on the back. Instead of using 1/4 inch for each output, I can now have 1 output and 2 inputs using 1/8" jacks. And I should be able to fit all of these in and still have the potentiometers and switches fit in as well. Let's give it a shot. And we are in business. This should work perfectly, provided that I drill the rest of these holes correctly. I'm going to do that now, and then I'm going to decide what to do for the rest of the LEDs and the other switches. That is a very tight fit, but this is going to work out perfectly, I do believe. What I need to do next is decide where the power switch is going to be. I originally had the power switch here, but the DC jack is actually now going to be here. So what I think I'm going to do instead is I'm going to use this side to have the 4 switches that activate the positive voltage into the second input of each of the LFOs. And that way, since I've already got space taken up on this side, they'll be all running along the side of this part, and then I'm going to have the LEDs living in here. We are almost finished. All of the holes have been drilled except for the LEDs. Here are the 4 switches on the side now. Those 4 switches are going to control when the voltage coming out, 5 volts, goes into input 1 of each of the quad gates. And then 4 more LEDs over here. And the LEDs are going to go somewhere on the top. I'll worry about that later. I might go ahead and release this as part 1, and we'll pick it up in part 2.